Please join me in welcoming Dr. Wolfgang Gentzsch.
Thank you very much, Mike, as always. Okay, so thank you for having me here. John, congratulations. 25 years back, my first HPC conference was in Mannheim. That was the other one, the ISC. And so you started earlier, which is a real achievement. Still around, which is, we all appreciate that. So 3 years ago, almost exactly, I got into DEISA after a few larger and larger projects. That basically still currently is my largest one. Before that was DECI, setting up a research infrastructure for the German researchers, connecting 24 of the largest supercomputer centers. And basically what I learned at DECI, I could immediately apply to DEISA, which connects 14 of the largest supercomputers and supercomputer centers in Europe in a federated structure and in an orchestrated way. And so it makes a lot of sense because after 1 year DEISA, I was here introducing the DEISA project. So 2 years later, now we are just 1 month before ending it, and in end of April, DEISA will basically merge into PRAISE, which is the Partnership of Advanced Computing in Europe. So all the infrastructure which has been built over the last 6 years is now being used as an access platform to access the largest currently petaflop and at one point in time, as Mike already announced, exaflop systems. Okay, so I believe it's a good moment in time to look back, wrap up, and finally provide some lessons learned and recommendations on this quite complex infrastructure, quite complex community, and very wide spectrum of applications. So there are quite a few guys who, together with me, collected these lessons learned and recommendations. So I sent an email around to, these are the leaders of the work package, basically, which you see there. And everybody asked in their community, so what was most painful, what was most successful, etc. And so this is, the second half of this presentation is about that. The first half is just basically summarizing again the DEISA project as it is today. DEISA is part of what the European Commission defined as an HPC ecosystem in Europe, which on the top you have, as I mentioned just before, the PRAISE supercomputers, so to speak. Currently, this is Jülich, and we already heard the French Nuclear Research Center, and the next one will be Munich, and the next one Stuttgart. So they all will have 2 to 5 and later 6 and 10 petaflop over the next 2 years. That's the plan. And so every country contributing to PRAISE has committed to put around 100 million euro on the table over the next 5 years to operate this supercomputer as part of PRAISE and to provide cycles and support and expertise to invite users with big challenge, big science grand challenge applications to the infrastructure. And so you will see some more results later. The next level, what we call Tier 1 in Europe, then currently is DEISA. And the level DEISA is currently taken care of is moving into PRAISE as well. So DEISA over time will host the Tier 0 and Tier 1 supercomputers in Europe. And so besides those who put each these 100 million euro on the table, there are 20 plus more associated partners who provide in-kind, provide expertise, application, etc., support for this infrastructure. And finally, we have the successor of EG, which we had from 2000 onwards, the EG 1, 2, 3 projects, and now it is EGI, the European Grid Initiative, which basically combines over 40 partners into a European, more generic grid initiative. Okay, so back to DEISA. And these are the countries and the 14 supercomputer centers, which a few of them have already been mentioned this morning, like Barcelona and Jülich and others. And so DEISA is a 6-year project running from May 2005, and you see April 2011, so until next month. And then I'm jobless. Not really, I guess. So orchestrating Europe's most powerful supercomputers for the most challenging projects, scientific projects, grand challenge projects performed on a regular basis. And so that it's about the top level, Europe-wide application enabling. So that's a task, which is, says application task force, with representatives in all the different centers. And over time, they got more and more complementary. So you may not find, for example, plasma physics expertise in all the centers, which basically would be a replication and waste of money, which there is not so much around. But there is one lesson learned in that respect, which is you ideally want to have at least one backup. So there is 1 or 2 experts in a certain field, and then there are another 1 or 2 or 3 somewhere as a backup, because these people may move around, may be on vacation, etc. The topmost priority in these kind of projects, this is the end user and his or her application. And obviously, for good reasons, these end users don't want to wait for too long. So they want to have ideally immediate support whenever something breaks. And okay, finally, DEISA invited, 3 years ago, started inviting the larger virtual science communities in Europe and provided all kind of support for them as well. So not only individuals and 2 or 3 colleagues or so, but larger science communities in plasma physics, in bioinformatics, and a few others who basically have their own responsibility. They get a big slot of CPU cycles in the order of 10 to 20 million or so, while an individual project is usually getting 1 to 5 million so CPU core hours for their project. The communities are getting a much bigger chunk. And then they can administer their chunk according to their needs and the needs of their members within this science community. Okay, so in the very beginning, and still today, we see these 14 supercomputer centers all over Europe, with certainly the hardware and the storage, and on top you have these very individual, very customized, very almost proprietary, because after so many years of operation, every supercomputer center got its own software infrastructure, software stack to operate their own supercomputing HPC infrastructure. So SE stands for software environment, and that was one of the challenges in such a project, because these software environments, each of them, they were different, and they are different. And therefore, number one was that a dedicated 10 gigabit per second network has been established. The access is through the European Géant 2 network infrastructure, which connects the national NRANs all over Europe. And then underneath, DEISA, together with, in the beginning, it was IBM, and then later on more and more partners, enhanced the global file system, the GPFS, into an MC, multi-cluster GPFS, to connect basically all the more local file system infrastructures into a large virtual one. So on top of all these software environments, the different software environments, then DEISA developed a common production environment. So whenever scientists move around, visiting their colleagues at a different location, they now face and they see always the same software stack infrastructure, so the access to the different software tools to support their development and running of their applications. And the access is through the internet, through enabling or offering single sign-on, secure shell, Unicore, which is the European grid middleware widely used there, developed from 1995 to 1999, basically, and grid FTP and a few additional grid components. The main task of DEISA is to provide services to the scientists all over Europe, plus their colleagues in the other continents. And it's mainly three categories. It's operations, technologies, and applications. So the nice thing with that is that a supercomputer center with a history of 40 years services in this field, I mean, they have their own triangle, service triangle, so to speak. And now they all got together, and the challenge was to basically make those triangles as similar as possible and to merge them, you see these sides, and merge them together into one orchestrated operation environment. So it's about federated operations. Another lesson learned is, so don't touch the local culture, don't enforce things which locally the operators and the administrators are not used to, because they have built and operated other things for many, many years already, but instead introduce a federated architecture of services, which, you see, I mean, every supercomputer center provides a similar set of services for good reasons. There is no secret that everybody has to provide network services, AAA authentication, authorization, accounting, and all these things. And so after about 1 year, DEISA achieved this kind of structure with introducing some additional task leaders, which who usually are task leaders already in their center, and got an additional responsibility to coordinate or to orchestrate their part of the services over the 14 participating supercomputer centers in the DEISA project. And so you have site deputies on the horizontal, on the vertical level, and you have one head of operations who basically drives the strategic meetings and is responsible for orchestrating everything, while the real work is done underneath, as it was done and is done in the local centers already. So there is, with this federated structure, nothing is really new. It is basically the only layer on top is more the orchestration layer, with sometimes additional tools, but mostly, I mean, very standard tools like telephone conferences, video conferences, even emails with aliases and then all that well-known thing. I will get back to some of these later in the context of lessons learned and recommendations. So why are we doing all that? The utmost highest priority has the user and his application. So that's why in 2005, in the first year of the project, DECI has been launched, which is the DEISA Extreme Computing Initiative. And it's about complex, demanding innovation simulations requiring these DEISA resources, and encouraged our multinational proposals. This is one of the almost requirements. We are in Europe, so for good reasons. And the proposals are reviewed by national evaluation committees. Projects are chosen on the basis of innovation potential, scientific excellence, relevance criteria, and national priorities. So usually about 50% of the proposals are accepted over the time, and I get into some statistics a little bit later. Most powerful HPC architectures are for the most challenging projects. One of the tasks of this review committees was to assign a priori or to suggest a set of systems which were most suitable for a specific application. We have to say, and another thing we learned is, and I'm sure TeraGrid and OSG have learned it the same way, these supercomputers are not primarily used as a grid. One of the benefits is whenever locally you don't get your 1,000 cores you need, or your 10,000 cores even you need, because of a long waiting queue there, some of the other supercomputers may be available and exactly have the size of the performance the number of cores you are requesting. So that is one. So usually you get faster to the system you need. On the other hand, there are about 15% of the projects which really needed 2, 3, 4 of the supercomputers and who could nicely make use of that because they were, for example, providing a workflow with different computing nodes, like in multidisciplinary multiphysics applications. There is the material component and then the fluid dynamics component. So like in fluttering of wings or so, you have very often very different components which also require different architectures, more tightly coupled, more loosely coupled, etc., depending on the underlying algorithms of the different nodes in this workflow. Yeah, okay, so this is some statistics of DECI, the DEISA Extreme Computing Initiative from 2005 to 2010 in the last 6 years, and with increasing number of projects and increasing requirements for processors and cores then. So that's okay, clear summary. The last few slides are about lessons learned and recommendations, and we ask the management, operations, technologies, applications, and user support, work package leaders and their teams, and so they nicely helped me to collect a couple of these things. Unfortunately, usually these things are quite boring, so I apologize for that. And just to demonstrate, and these slides are certainly available for those who want to do similar things and start from scratch or whatever, and or want to cross-check so how they are doing. So usually I put 6 or 7 of these lessons learned and recommendations on a slide, which I won't show all because it's really, it's kind of boring. So Number one is, hey, we have a distributed project, meaning not only the resources are distributed, but the people, the support, in these operations, technologies, applications, categories, they're all distributed. So most important is you want it from the very, very beginning, from the very first day, and everything should be written down, because people tend to start fighting when they think they are right, and maybe they are right. So you want to agree on strict rules for communication and processing. Unfortunately, this is a little bit more formal, more bureaucratic, but this is extremely important. And the other very important thing is respect the well-established local policies of the individual partners. Don't mess around and come with new ideas and new things and new processes, etc., but respect what they have and build everything else on top in a more coordinated, orchestrated way. And this red thread, so to speak, goes through all these slides at the end of the day. And so concentrate on orchestrating the services as a layer on top, so that's what I mentioned, and so on and so on. So let me just skip that one and give you 2 or 3 lessons learned and recommendations from the operations team. So you want to really focus on coordinating day-to-day operations of services. So and again, you want to really define how that operation, how that coordination of the operations really works on a day-to-day. So everything ideally beforehand, well-defined, written down, and so the local teams monitor and maintain their local services, and they collaborate on the integrated services between the sites. So their primary focus is always and still their local stuff. Don't really disrupt too many things too much, but again, try to coordinate and really make use of their expertise from the local level and level it up one into more the orchestration. Define SLRs, fallback solutions, prepare for surprises. In a complex infrastructure, there are many surprises almost every day. Change management, responsibilities, and so on. Documentation. So that is key. So technologies, so they recommend technologies should be driven by user requirements and technology innovation. So these are the 2 big reasons why also technology-wise you have to move forward to provide always the best possible services for your end users. Heterogeneous thing, I mean, with this huge variety of hardware, software, services, everything is heterogeneous. So exploit and leverage the differences instead of homogenize everything brute force. Again, and so on and so on. There are some signs that I want to hurry a little bit. Most important is applications enabling. You want to take the users by the hand and port their codes to these machines, which are, changing. There are always new machines coming up, old machines moved out. So you want to help the users almost hide this complexity underneath. Because these codes, these scientific codes, are usually very complex. While the nice thing is mostly you have your hands on the code. So these codes are very often homemade, so to speak. Okay, so this is the most important thing, is the application task force. And over 14 centers, every center already had and has their own application task forces. This is a very powerful group of expertise in porting codes and optimizing codes to the best suited systems underneath. The application task force collaborate with operations because a user might want to have a certain configuration of systems, and with the technologies team because a user might have additional technology requirements, and you want to have really shortcut influence into the technology and into the operations team. Range of architectures for different codes is a nice thing. 14 centers, almost 14 different architectures. So you have a real nice choice as a user. But you need to support this. A user herself cannot really easily identify the best suited system in this network, etc., etc., etc. So users relation and support and user support comes back with users only. Yeah, so this is one interesting thing. You don't hear anything as long as things are going nicely. What you hear from 14 different centers and their users, that's always the real complaints. And that might demotivate you because you only hear the complaints. They never come back and say how great you are. So that might be a little bit frustrating. And users are conservative. I mean, everybody is conservative, almost everybody. And among others, this means never change a running system, don't disrupt users too much in their daily operation, which they are used to do already for 10, 15 or so years. And always have a second expert just in case, and more and more and more. Again, these slides are available. Someone will put it on somewhere on the web. And I have not figured out with John before, and I should have, but I can build up my own website if you force me into that. So sustainability is, and I think it's my second last slide. So from the very beginning of the infrastructure project, think about sustainability. I mean, usually a project is 3 to 5 years, and you invest so much money and take away so much time from the people who focus 5 years on that one. And what a disappointment if everybody disappeared at the end of the project. So the nice thing with DEISA is, which I already mentioned, the whole infrastructure and the expertise and the people, they are moving into PRAISE now, and PRAISE will live for another 10 years or so, until we at least, with JAX and other help, the exaflop period. And so the second one is DEISA applied this federated sustainability model, which every component should be sustainable in itself and not really depend on sustainability of others and say, okay, you are doing the sustainability and I don't care, basically. The nice thing with these existing supercomputer centers is they are sustainable already for 40 years. They know how to do this on that node level, and now you have to guarantee a similar sustainability across these things to reduce or eliminate technological, cultural, economic, English is, okay, I'm sorry. So, be aware, there are some additional slides about sustainability and about the sustainability of the individual components: technology, operations, expertise, communities, collaborations, which means basically the community has to be there and vibrant and active. Otherwise, there would be no requirement or request for such an infrastructure, etc. And here are some of the arguments, etc., etc. So, take a deep breath. The summary finally is, I mean, for me, 3 years, DEISA was a great project. Yeah. I mean, there are hundreds of great guys in this project, and working with these innovative and creative and relentless guys was always a pleasure. I think I did about, so I counted it, I did about 56 presentations about DEISA in the last 3 years. And I'm still not tired. So, okay. Okay, so DEISA, designing, deploying, operating a persistent European HPC infrastructure. Done. 6 years of successful DEISA in production. Done. Hosting more than 450 grand challenge computational science projects. I mean, this is a great success, really, with thousands of publications, by the way. I mean, there's a huge list of those, which came out which made use of this DEISA infrastructure. So the researchers came from 37 countries together with their colleagues from the Americas, Asia, and Australia, and supported by well-established European expert teams, not only applications, but computer science, etc., and gaining sustainability and persistent under praise. Again, praise is now what you should focus on in the near future over the next 10 years. This is the Partnership for Advanced Computing in Europe, and it is integrating Tier 0 and Tier 1 HPC series supercomputer systems. Okay, thank you very much. This was my last presentation about DEISA. And I'm sure in my life. So next, someone said next maybe praise, but I'm sure it's very different, and I will tell you next year. Thank you very much.